Okay, let's extend our discussion of covalent bonding into covalent bonding with multiple bonds. So again, a covalent bond is a shared pair of electrons. And at times there's going to be two atoms sharing more than one pair. If we look at, let's just as a quick review of covalent bonding, look at a simple molecule H2O, water. Oxygen, again, is in that column. It has 6 valence electrons, so let's show the Lewis structure for oxygen. 6, it needs 2 more to have the 8 that it needs. So in comes a hydrogen, comes in and shares. Right, and then I bring another hydrogen into this side. And so by sharing with 2 different hydrogens, the oxygen has the 2, 4, 6, 8 that it needs. And so that's all done. This is called a covalent bond, but also a single covalent bond. And we will frequently kind of clean it up. So 2, 4, 6, 8, we're showing that by showing a covalent bond as a line. The line represents the 2 shared electrons. So more frequently, water will be shown like that, right? With showing the covalent bonds, the 2 of them, as a line. Now let's look at another very common substance, oxygen gas. Which is O2, 2 oxygen atoms bonded together. So if I show oxygen, 6 valence electrons, and let's snap in another oxygen on this side and have them share to make a covalent bond. In this arrangement, 2, 4, 6, 7. Oxygen doesn't have the 8 that it needs. This would be a very unstable arrangement. So what they can do is they can take, well, here's a unpaired electron, bring it into the center. Unpaired electron, bring it into the center. So they can share more than one pair. They're already sharing one pair. They're going to bring these 2 that are not paired up and pair them up as a second covalent bond. And this is how the arrangement of valence electrons in the oxygen O2 molecule is. Some of the electrons, valence electrons in oxygen, are unshared pairs, but there are 2 shared pairs in between them. That is called a double covalent bond. And since a covalent bond can represent a line, can represent a pair of electrons, what we'll frequently do for a double covalent bond, I've got a pair and another pair, so 2 lines. That would be the Lewis structure for O2. Another arrangement, let's look at 2 possibilities. Let's look at C2h6, which is ethane gas, and C2h4, which is ethene gas. If I look at the first one, of course, the carbons are in the center. Why? Because, as from the last video, the carbons can make 4 bonds. So connect the 2 carbons together. Hydrogens are always on the outside because they only can make 1 bond. Bring in the 6. 3 on each carbon. And I have my ethane molecule like this. All single covalent bonds, right? Which we can replace with lines, and frequently do. To get this. So this, of course, is a very common gas, lightweight gas. So is ethene. C2H4. So I got 2 less hydrogens to work with. Connect the 2 carbons. And I have that. 4 hydrogens now, not 6. So let's put 2 hydrogens on each carbon. There's my 4. Now, unlike here where I could bring in 2 other hydrogens to replace that, in this case there aren't any more hydrogens. So carbon 2, 4, 6, 7, not enough. What's it going to do? Bring these 2 in as a second covalent bond between the 2 carbons, or make it a double covalent bond. Right, so I replace, so there's a total of 4 electrons, 2 plus 2, 4 electrons. I replace them with lines. That would be the Lewis structure. Let's double check carbon. 2, 4, 6, 8. 2, 4, 6, 8. So each carbon has what it needs. It has the 8 valence electrons that it needs. So there's single covalent bonds, like I'm showing here, and this molecule has some single covalent bonds between carbon and hydrogen, and double covalent bonds. There's also triple covalent bonds. The main substance in the atmosphere is nitrogen gas. 79% of the atmosphere is nitrogen gas. 2 nitrogens. This is nitrogen. 5 valence electrons. Let's connect 2 nitrogens together. And I have N2. Now, of course, by doing this with just a single covalent bond, not even close to working. 2, 4, 5, 6. Let's bring in these 2 and have them share. Still won't be enough. I still got 2 unpaired electrons here on the outside. Bring them also in. So these 2 nitrogens are going to share this original 2 plus these 2 plus these 2, a total of 6 valence electrons. And that will be our arrangement for nitrogen gas. A triple covalent bond. So there are single covalent bonds, those are the most common. There are double covalent bonds, and there are triple covalent bonds that are possible. No quadruple covalent bonds. So that's a triple covalent bond. Let's clean it up a little bit. Show each pair as a line. And there's our Lewis structure for N2. Both of these would work. Let's look at another one that would be triple. Okay, so we did a few molecules. We've done C2H6, and that worked with all single bonds. And then we did C2H4, and we had to put a double bond between the 2 carbons. What about if we go C2H2 Acetylene gas, another common molecule. So I've got the 2 carbons again, so let's connect them. But now I don't have as many hydrogens to use, so let me 2 hydrogens, let me put 1 on each carbon. And we can see the carbons aren't close to having the 8 that they need, so they got to do some more sharing. And again, if they're adjacent atoms and they have a lone electron, bring those lone electrons in and have them do more sharing. The 2 carbons are going to share that original pair plus this pair, so that's 2, 4, and then this one, 6. And then let's change and replace each pair, each covalent bond with a line. And we get that one. So when you need to do more sharing, if they don't have the 8 that they need, just bring some of those unpaired electrons in and make multiple bonds. So triple covalent bond there. Let's look at a couple ones. So sometimes the molecules get bigger. Let's look at a couple of those and see the reasoning that we go through. When do we need a double bond? When do we need a triple bond? Let's first look at this one. This is acetone, very common in nail polish removers and as degreasers and stuff. So CH3COCH3. Why do we write it this way? It's got 3 carbons. Why don't we just do C3, 6 hydrogen H6O? Because when we write the formula, we want to give a little hint of how this molecule is put together. Let's connect the 3 carbons together. 1, 2, right? And then 3. So each of the 3 carbons is in a line sharing a pair. So I've just taken them, snapped them together. According to this formula, 3 hydrogens are on this first carbon. So I can see this carbon's taken care of, 2, 4, 6, 8. There's an oxygen. Remember, oxygen is this, 6 valence electrons. I'm going to bring an oxygen. I could attach it to the bottom. I'm going to go ahead and stick it on the top. Just bring it in and connect. And then 3 hydrogens on this last one. And then we have to stop and look. Once we so at the first step, just take these things and connect them using single bonds. This carbon, 2, 4, 6, 8, this carbon's good. It's got what it needs. This carbon, 2, 4, 6, 7, not quite there. Let's check this one though, 2, 4, 6, 8. So that one's set. And this oxygen also not set. So I don't just pull in 2 electrons from anywhere. I say, well, where's my unpaired electrons? Are they on adjacent atoms? They are. Bring them in and share and make a multiple bond. So let's write this. I've got this carbon here that's now sharing 2 pairs with this oxygen. A lot of dots. And I get that. That would be the dot structure. Let's replace the covalent bonds with a line. It's a lot cleaner when we get to something like this. So the carbon connected to 3 hydrogens, connected to that center carbon. Double bond up here to the oxygen. Don't forget the unshared pairs. Got to show the unshared pairs. And then it's connected to this carbon. So notice all of the valence electrons in this molecule are being shared except for those 2 unshared pairs on the oxygen. And that is the structure for acetone. One more. And then we'll have a Google document with some practice. CH3CN. And then, so let's connect. Of course, the hydrogens have to go. The hydrogens are going to go on this carbon. Carbon connected to the second carbon. Connected to nitrogen, which is, remember, 5 valence electrons. Bring it in and make the connection. And now, what do we got? What else do we got? We have 3 hydrogens that we're going to attach to this guy. And that's it. We're out of hydrogens. We could put more hydrogens here to make single bonds, but we don't have them. So what do we got to do? These guys are going to have to do some extra sharing. Bring this loner in here and this one in here. Close. We're almost there. I still got 2 that are unpaired. Bring in. Bring in. How many? 2 plus this 2 plus this 2. A total of 6 electrons. Let's clean it up. So I'm showing these 4 bonds with just a line. And then these electrons move to the center. So this carbon has 2, 4, 6, 8. It's surrounded by 8 because it's got a single bond here. That's a pair. A triple bond here with 3 pairs. That's a total of 8. This nitrogen, 2, 4, 6, 8. And they're good. So it's just about that. Look at that process. Connect them. Do multiple sharing if some of them don't have the 8 electrons that they need. and then let's practice this some more.